Hi everyone, this is another production of Conalenzo Inc. We're going to be talking today about systems of equations, and I want to give you a short little introduction into what they are and what we can do with them. So our goals for today are to be able to understand and explain what a system is. We want to also be able to classify the type of system and to find the solution of the system graphically, which means yes, we're going to be using a graph. So, what exactly is a system of equations? It is two or more functions graphed on the same coordinate plane. And I use the word functions kind of loosely because they're not always functions. But just to kind of give you an idea, it doesn't have to just be lines. Okay, so this one that we're showing here, we've got two lines graphed on the same coordinate plane. You can see the green one is going in a negative direction. The red one is going in a positive direction. They cross at the point 1, 3. We could add another line if we wanted to, and it would still be a system of equations. We could graph 5 lines on the same coordinate plane, and they would still be a system of equations. There are 3 different types of systems that you can deal with, specifically when you're talking about linear systems, where we have the graphs of 2 lines. First of all, they can intersect at one point, and they have exactly one point of intersection, no more, no less. That would be a consistent and independent system. Now, the second system here has the same lines, which means that they have infinite number of solutions. Because they touch at every single point, there's an infinite number of intersections because they are the same line. This system is called consistent and dependent. The last system that we look at has parallel lines, and we know that parallel lines never cross, so there's no solution. The solution of a system is the point where they intersect. And because parallel lines do not intersect, they do not have a point of intersection, which means they have no solution. This is what is called an inconsistent system. So we have 3 types of classifications. You do need to know the names of each one and what they mean, okay? Remember that the whole point of this is to find the point of intersection where they cross, and each system is classified based on whether or not they have 1 point, infinite points, or no points of intersection. Now, to solve graphically, you simply graph the lines and see if or where they intersect. So I'm going to graph this first line, and I'm going to graph it at positive 1. And then I'm going to go down 3 and over 1. Now, when I'm graphing, I want to kind of keep doing this and do it for several points. I'm also going to go up 3 into the left 1, just to kind of continue my line so that I can see a point of intersection, okay? And then I'm going to graph the second line. I'm going to do it in a different color. 3x plus y equals 6 means that my x-intercept is at 2, so 2, 0. And my y-intercept is at, 6. 1, 2, 3, 4, 5, 6. And then I can see that that's over 2 and up 1, 2, 3, 4, 5, 6. That'd be the same as over 1 and up 3, or to the right 1 and down 3. And I can see that these are very clearly, okay, well, maybe not very clearly because my drawing is bad, but these are pretty obviously parallel lines, which means there is no solution. Okay, remember, we can also write that like this, because they will never intersect. They do not have a point of intersection. Because they are parallel, they do not intersect, okay? I'm going to graph these ones as well, and we're going to see if or where they intersect. So remember, my first one is in slope-intercept form. I'm going to go down 7, 1, 2, 3, 4, 7, and then I'm going to go up 3 and over 4. And I'm going to make my line. I'm going to try to connect those points. Oh boy. Try to make it as straight as you can. That helps. Again, not always perfect. This is why we use graphing tools like Desmos, because they graph nice straight lines, unlike your teacher who can't graph them very well. My second here is in standard form, so I'm going to find my intercepts. My x-intercept is at 28/3, which is approximately 9 1/3. 1, 2, 3, 4, 5. So right about there. And then my y-intercept is going to be at -7. Probably should have done this in a different color. Let me switch real quick and do a green. Here we go. There's my green, and then -7. And I can see that these are, although poorly drawn, the same line, which means that I'm going to have an infinite number of solutions because these lines are going to intersect at every single point where they touch, okay? So graphically, we can kind of see where the lines intersect. It makes it a little easier to tell. And we just graph these lines, or we use our nice graphing programs like Desmos, etc. Okay. Now the question comes up: can there be more than one point where they cross? The answer is yes, if, and this is a big if the system includes some sort of curve. Okay. So a conic, like we've talked about, a circle or a parabola, um, the line could cross in more than one spot. Now you still have that option of where it doesn't cross at all. So maybe there's no solution because they don't touch. There could be one solution where they touch at one spot. This is called a tangent line. A line that touches a curve in exactly one point is called tangent. We could also have two solutions where it crosses at two spots, and that would be the most common, that your line is going to cross your conic at two spots. So there is possibility that we could actually have two solutions. Depending if we had, let's say, two circles, we could have four solutions, or a parabola in a circle. It just kind of depends on what your system is. Now, if it is a linear system, two lines, you will only have one solution, or no solutions because they're parallel, infinite solutions because they're the same line. And we're going to be focusing on linear systems. Just kind of thrown out there so that you know that if there's other things involved, not just lines, we can have multiple points of intersection. Okay, so I hope this kind of makes sense for you and that you are understanding what we're talking about here with systems. As always, if you have any questions, let us know. This has been a production of Con Alonso Inc. Take care.